In this video, I'm going to show you how to do a chi-square test. So the file we're going to use, it's one of the OpEx files, of course. We're going to the chi-square with detail worksheet. This is a file that's based on the original OpEx file, but I've added separate detail. So use the chi-square with detail worksheet. And that. So you can see we've got two worksheets. The detailed data worksheet is the one that comes up. And what it shows you is in column one, you have the customer satisfaction level, satisfied, unsatisfied, and then the area in which the survey was taken. So unlike in the two proportion test or just A and B, in this we've got C and D as well. In the summarized data tab, you can see that the counts by area and by level of satisfaction have been made here. The textbook uses this sheet, so we'll start here. All right, so when we're performing a chi-squared test, what we're looking at is proportions for more than two groups. Right? In one proportion test, we were looking at the proportion of values in a data set compared to a benchmark or an external value. In a two proportion test, we're comparing the proportions in two samples against each other. In a chi-squared, we're talking about more than two proportions. So the null hypothesis for chi-squared tests would be there is no difference in the proportion, in this case, of the customer satisfied by area. The alternate hypothesis would be at least one area is different. So the null is there's no difference. The alternative is at least one of them is different. So I'm going to go through this test kind of multiple times here. We're going to go through it with the summarized data and then also with the detailed data. Get the same result because the summarized data is based on the detailed numbers. I'm also going to go through it methodically. They're going to show you how the test works. So to do the chi-square, in this case, we're doing a chi-square test for association. Go to Stat, Tables, chi-square test for association. You can see the tooltip there says we determine whether two categorical variables are associated. It defaults to raw data, but we have our summarized data, what's called a two-way table, meaning we have rows and columns. So the columns containing the table, in other words, the counts for each of the inputs. In this case, the input is the X is the area. We're saying that the level of satisfaction, or hypothesizing the level of satisfaction depends on the area that was surveyed. The labels for the table sets the rows, the row values. That's going to be column C1. And the label for that is level of satisfaction. All right. If you click on the statistics button, you can see that a number of things are already checked. That's fine. Leave those defaults in. Click on OK. Click on OK again. And you can see what it does is it summarizes the data in a table right here, just like this table. Although what it's done here, it's also produced what's called the expected counts. So let me just go through to the results. I'll come back to this table that we need to create it here. The result that we're looking at is going to be the Pearson chi-square test. And the statistic we're looking at here is the p-value 0.029. That p is low. It's below our alpha of 0.05. So based on that, we would reject the null hypothesis and conclude at least one of the areas is different in terms of the proportion of customers satisfied. Right. Now I'm going to come back up to this table here. So you can see that this little key right here tells you how to read what's in this table. So the cell contents are the count and then the expected count. You can see that the count here, 72, 79, 35, and 9, that all corresponds to those counts there. And then down here, the not satisfied, 8, 21, 15, 1, 8, 21, 15, and 1. So the counts are just repeating what's right here. The expected count has to do with if we make the assumption that there is no difference in the distribution or the proportion satisfied across the different areas, then we would expect to see the same proportion satisfied versus not satisfied in each area. So if I count across this row, so I have 72, 79, 35, and 9 who are satisfied. That gives me a total of 195. The not satisfied, 8, 21, 15, 1, that's a total of 45, right? 195 plus 45 adds up to 240. So that proportion, and I'm going to pop open the calculator here, that proportion satisfied, 195 divided by 240, is 81%. So if there is no difference in the proportion of customers satisfied by area, then regardless of the total size of each area, we'd expect about 81% to be satisfied. So in area A, the total number of customers is 80. If 81% of our customers are satisfied, we'd expect that to be 65. So you can see over here on the calculator, 0.81 times 80 equals 65. So these expected counts are taking the overall proportion, the total proportion, right? And then applying that to each area. So in area A, if 81% of the customers are satisfied, we'd expect to see 65 satisfied customers. In fact, however, we actually saw 72 satisfied customers. We saw more than expected in area A. In area B, we would have expected out of 100 customers, 81.25. We saw 79. That's fewer than expected. In area C, out of a total of 50 customers, we would have expected to see 40.63. We saw 35. Again, that's fewer than expected. And then in area D, out of 10 customers, we'd expected 8.13 satisfied customers. We saw 9. That's higher than expected. Now, you can see that some of these proportions are kind of close. I mean, 9 out of 10 customers versus about 8 out of 10 customers, 79 out of 100 customers versus about 81 out of 100 customers. Those proportions don't seem to be so different. This seems, area A seems to be different. If you look down here, so the converse would be true, right? So if 81% of our customers are satisfied, then we would say that about 19% of our customers should be dissatisfied, right? So out of 80 customers, 19% would be 15 customers. We saw 8. That's fewer than expected customers dissatisfied. In area B, we would have expected 18.75 dissatisfied customers, so 21. It's a little bit more than expected. Out of 50 customers in area C, we would have expected 9.38 dissatisfied. We saw 15. That's a few more than expected. In area D, we'd have expected 1.8. We saw 1. That's pretty close, but it's slightly smaller. So the p-value here, though, tells us that statistically speaking, at least one of these areas is different. So then, falls to us to try to figure out which one of those areas is different. When you use the default settings on this test, this is the information it gives you. You get a low p-value, and you have the actual and you have the expected counts. And what you know is at least one area is different. If I make a slight change to the default settings, because I need to know, okay, statistically at least one's different, but which one? I'm going to go back, I'm going to redo that test, right? Using the same data and the same fields here. I click on the statistics button, and then I click on each cell's contribution to chi-squared. Now, what that means is if we were doing this chi-squared test by hand, we would be looking at the difference between the observed and the expected and making a chi-square calculation. Then when we're done doing all those chi-squared calculations in each cell, we'd add up that total chi-squared statistic. And based on the number of rows and based on the number of columns, we looked that up in a reference table, and it would tell us whether or not there was a statistically significant difference in one of the areas. I'm not going to make you do that by hand. It's a lot of work, it's a lot of math. We don't need to do that. Minitab will do it for us. But by showing each cell's contribution to chi-square, we can get a clue as to which of these cells in this table Minitab sees as being different from the others. So I've chosen to show each cell's contribution to chi-square, clicking OK, clicking OK again. I get the same results down here. But you'll see I have a new layer in each cell. So I've got my observed counts, my expected counts, and then the third row is the contribution to chi-square. Right? Now what you can see is these numbers are fairly low. They're all point something. It's 0.7, 0.06, 0.7, 0.09. You can see area C and area B satisfied customers. Those numbers are a little higher in area B and D. But then under the not satisfied row, you can see the chi-square contribution in area A, 3.2, compared to B of 0.27, area C, 3.37, compared to area D, 0.4. So by looking at these the chi-squared statistic, or the contribution to chi-squared statistic in each cell, I can see which cells Minitab sees as being more different than expected. And so what this tells me is that area A and area C are more different than expected than area B and area D are. So I've got a p-value that's low, tells me I can reject the null hypothesis and conclude at least one of these areas is different in terms of its proportion of satisfied customers. By looking at the chi-squared statistic, I can see that it looks like area A and area C are the ones where the most difference lies. So if I am looking for a clue as to what kind of action I need to take, in area A, I'm seeing more satisfied customers than expected. In area C, I'm seeing fewer satisfied customers than expected. Those might be the areas to look at. What am I doing right in area A? What am I doing wrong in area C? And then go to work. Now, this is all done with the summarized data here. You click on the detailed data. You can see you've got a row for every response to the survey. The counts of those rows add up to the summarized data here. If I happen to have detailed data like this, rather than summarized data, I can still do the chi-square test for association. I just have to set it up a little bit differently. So again, I would go to stat, tables, chi-square test for association. Instead of choosing summarized data in a two-way table, choose raw data. And so that asks me which column contains the row labels. I'm sorry, yeah, which column of my data contains the row labels, and then which column contains the column labels. If you remember, our y is a function of x formula. Minitab, generally speaking, asks for the y first, the output. In this case, it's the level of satisfaction. The input, the difference we're looking to see, if there's a source of difference, is the area. So the rows would be customer satisfaction, column would be area. You can see it's remembering the options that were last chosen for this test and left in each cell's contribution to chi-squared. Okay. And I have exactly the same results as I did before. You can see my observed counts, my expected counts, and then each cell's contribution to the chi-squared statistic. And then down here, the Pearson chi-square test p-value. That's the one we use, the Pearson value, not the likelihood ratio. So chi-square test is analogous to the ANOVA. When we're doing tests of averages before, one sample t-test, a two sample t-test, and then ANOVA. When we're looking at proportions, you get a one proportion test, a two proportion test, and then chi-square.